Hello students, today we are going to continue with the same topic of friction, and we'll be doing the numericals based on inclined plane. You will see the inclined plane here. Turn with me to page number 283. So we'll start with example 15. I will do all the example questions, which will sort of give you a general idea about how to do this numericals, which is based on inclined plane. So before going to this inclined plane, you already know this one, mg sine theta, it always acts downwards, and then the frictional force acts upwards when the body is sliding down. So accordingly, you already write in the test also, you will have a good idea about what it is. So a body of mass m, mass is 10 kg, is sliding on the surface inclined at an angle of 30 degrees with a horizontal. Calculate the acceleration of the body. Coefficient of friction is given here as mu is equal to 0.5. So draw a diagram straight. So a body is, now it is sliding down, and this is already 30 degrees and 10 kg is this one. So we know already, whenever we put this one, what is this one acting? Downwards is mg, and acting this side is r, and here you will have, and this one you will be, next one will be having theta, mg cos theta and mg sin theta. This is sliding down. What is this one? Sliding on a surface of an inclined plane, right? So it is just sliding is given here. It is not written. A body of mass m is sliding on the surface of an inclined plane with a horizontal. That means it is just sliding down. It is sliding down with an acceleration here. When it's sliding down, the frictional force will be acting upwards here. You already know this one. So mass 10 kg, mu is equal to 0.5, and then theta is equal to 30 degrees. Now write down along horizontal. Along horizontal, what will happen? What are the forces will be acting along horizontal? This is coming down and friction is acting upwards. Mg sin theta minus frictional force is equal to m into a. So r, what is the next one? Along vertical, r is equal to mg cos theta. This is equation number 1, this is equation number 2. From 1, what happens? Mg sin theta minus, what is Fk? Frictional force is equal to mu times of r. What is mu? Mu into m into g, right? Now here r is already given here, so you can write down mg sin theta minus Fk. Instead of Fk, you need to write down mu. Instead of r, I am writing mg cos theta is equal to m into a. Equation is done. Now if you take mass common outside from this one and this one, this mass will get cancelled out with the other side of the mass. So we need to find out only the acceleration. So acceleration is equal to g times of, g is common here, it is sin theta minus mu cos theta. Everything is given here, you need to substitute and get the answer. It is g is equal to 9.8. 9.8 times of sin 30 minus mu is 0.5 cos 30. So 9.8 cos 30 is 1 by 2 minus 0.5 into, what is cos 30? 1 root 3 by 2, and you need to find out the acceleration. So finally acceleration will be equal to, the value given here is 0.6556. If you just do the calculation, you will get the answer, meter per second square. This is the first question here. Very simple, straight, nothing much. You need to just put this formula. When you just put this formula, then everything is fine. Make sure you make this formula proper. If you have any problem in this one, then the whole thing will not be right. Okay, we'll go to the next question now. Right, this is a little technical question. You need to be a little careful about question number 16. A block slides down an inclined plane of a slope angle theta with constant velocity. Underline this word, constant velocity. That means acceleration is 0. The first part of the question is acceleration is 0, then it is slowly coming down the line. Now, based on that, you can make few more conclusions. It is then projected up the same plane with an initial velocity u. So now it is going up with the initial velocity u. How far up the plane will it move before coming to rest? Will it slide down again? So there's a question. So the block, first one is block slides down inclined plane with a slope of angle theta. So that's the main part of it. So we'll try to draw the diagram here. So you have the same kind of an situation. Now theta here, it is now, that angle is not given here, mg, and then this is r, and this is the value of mg cos theta, theta here, this is r, and mg sin theta. Now it is coming down. What is acceleration? Acceleration is equal to 0 because it is coming down with the constant velocity. So how will the formula will look like? So you can write the formula along the vertical. What will happen? Along the vertical, what is the formula which will be looking at? So this will be equal to mg sin theta, and this is the frictional force Fk minus Fk is equal to m into a. Now since a is equal to 0, now this is the next step you need to write here, and then this is mg sin theta minus f. What is Fk? You have to write it as mu times of r. So what is r? R is going to be equal to opposite to this one, so mg sin theta minus mu k. What is that? Mg cos theta equal to 0. So what is the value here? So you can pull this value together and then make to the next side, and you will be able to get the value of mu. So mg sin theta equal to mu k mg cos theta. So that is the next one you will get. Or otherwise what you can do is, you can write it as mg sin theta equal to this whole value, you write it as Fk itself, okay, and keep it as equation number 1. Now the second case is there, when the body is now pushed upwards. When the body is pushed upwards, now when the body is going upwards, what will happen? The force is equal to, it is going to be equal to mg sin theta. Now this is the force will be acting here, and what is the friction will be there? Friction will be acting in the opposite direction, Fk, because it's going upwards. So this one, those two will be added together, plus Fk will be there. Now this is the value when it is pushed upwards, but look at this one, this is already here, Fk is going to be equal to mg sin theta. So you can write down mg sin theta plus mg sin theta, because this one is being substituted here. So it's going to be equal to 2 mg sin theta. That will be equal to F here. Now based on this one, you can write down mass into acceleration is going to be equal to 2 mg sin theta. So mass gets cancelled out. What is acceleration? So you get acceleration is equal to 2g sin theta. That is the value you will get. Now what is the question it is asked? The question is, how far up the plane will it move before coming to rest? How far? The distance you need to find out. So we need to find out the distance moved up, you need to find out, right? V square minus U square is equal to 2AS. Alright, so the final velocity is 0, and then initial velocity is going to be like this, is equal to 2 into, and what is acceleration? It will be retardation here, minus 2g sine theta. That's what here it is. This is what this answer is, minus 2g sine theta into s. So finally, what is s is equal to? So the distance s is going to be equal to u square upon 4g sine theta. How far it will go? This will go in this much of value it will go. That's all. With this we close. We have found the answer. The distance moved is going to be equal to u square upon 4 times of g sine theta. If any parameters are given as a value, then you can substitute and get the answer. Okay, it's quite simple. So once you got this fk value, you're going to substitute this one here when it is pushed up. There is a plus here because both of them are going to act in the opposite direction of the force. So it is going to be like this. And you get the answer as acceleration. Once you got acceleration, you will get the distance moved. We'll go to the next question now. Okay, let's read this question number 17. A block of mass 2 kg rests on an inclined plane which makes an angle of 30 degrees with a horizontal. The coefficient of friction between the block and the surface is given here. So what are the parameters given here? Mass is going to be equal to 2 kilograms and theta is going to be equal to 30 degrees, and then mu is going to be equal to under root 3 by 2, entirely under root 3 by 2. What force should be applied on the block so that it moves down without any acceleration? Without acceleration. Acceleration is going to be 0 here. So the same diagram again made so many times. We make the same diagram here. So this is 30 degrees here, and this is mg, and you get this one as mg cos theta, and this is theta 30 degrees, and this is going to be the value of r, and you get here as mg sin theta. Now what is given here? What force should be applied on the block so that it moves down? Force also, it is acting here direction, and then frictional force will be acting upwards. But without any acceleration. You just apply a force but without any acceleration. That means along horizontal, how it will be? These two are added here, F plus mg sin theta. These two are added here, minus Fk, that is going to be equal to 0. The final net acceleration is going to be equal to 0. This is the external force which will be applied here. Alright, so put the values here. F plus mg sin theta minus mu into mg cos theta is going to be equal to 0. Now all the other values are given here. You need to just substitute and get the answer. What force it is asked? Force you need to take it to one side and the rest everything to the other side. So you can write, take mg common outside. If it goes here, mu cos theta minus sin theta, you will get this one. If you take this one next side, it will become plus. This one goes to the next side, it will become minus, and mg has been taken common outside. What is mass? 2 kg. And what is the g value? They have not told any g value here. So what should we do? Should we take 10 or 9.8? Better to take 9.8 still always. So that is the way it will always go well. Mu is under root 3 by under root 2 into cos 30. What is cos 30? Under root 3 by 2 minus sin 30 is 1 by 2. Find the value, you will get 11 newtons. I'm just quickly finishing this calculation and finishing right now. It is 11 newtons you will get. The second part of the question is quite interesting. Now look at this one. What force should be applied, B part. Now what force should be applied without any acceleration? What force should be applied on the block that it moves up without any acceleration? Earlier it came down without any acceleration, going up without any acceleration. how will you do this one? Okay, going up, this is B part, going up without acceleration. Okay, that is acceleration is 0. So when it goes up, how will you be happening? This is going to be the force. You apply a force F here, and this one will not be here. This will be acting here, Fk. So how will you do it? It is going to be capital F minus mg sine theta minus Fk. That is going to be equal to 0 without any acceleration here. So what you can write, what is force is going to be equal to, take to both this one to the next side. It is mg sine theta minus Fk. Mg sine theta, sorry, it's plus Fk plus mu mg cos theta. So mg common outside, sine theta plus mu cos theta, and you have to just put the values here. Put the values here. What is 2 kg into 9.8 into sine 30 is 1 by 2 plus under root 3 by under root 2 into cos 30 is under root 3 by 2. You will get the answer as 30.6 newtons. Okay. So the last part is calculate the ratio of powers in the above two cases when the block moves with uniform speed in both the cases. Power is asked. What is power? How to find out the power? The power is going to be equal to power 1 upon power 2 is going to be equal to force 1 upon force 2. You can just make the ratio here because power is going to be equal to force into velocity, right? And here, if V1 is equal to V2, it is already given here. Both the velocities are equal, okay, in uniform speed in both the cases. So velocity and velocity will get cancelled out. So power 1 equal to power 1 of F1 upon F2, it is 11 upon 30.6. So you will get the ratio here, P1 upon P2. Going downwards, it is this much of newtons. Going upwards, it is this much of newtons. So it's going to be equal to 0.36 is the value. That's the ratio here. Alright, we'll go to the next question now. Question number 19. Yeah, I'm skipping question number 18. That question will be more relevant in the next chapter. So we'll go to question number 19. A body of mass 5 into 10 to the power of minus 3 kg, that means what is the value? 5 grams. This is 5 grams. Is launched upon a rough inclined plane, making an angle 30 degrees with a horizontal. So that's quite simple. 30 degrees is already given here. Obtain the coefficient of friction between the body and the plane. If coefficient of friction is not given, you need to find out mu. If there is a two parameters given here. If the time of ascent is half the time of descent. So time of ascent is half the time of descent. So you need to find out the ratio here. It is already given here. The time taken is half, and only timing is given here. Mass is given there. Angle is given here. Rest everything we need to find it out. Right. So first of all, what we need to find out is, it is going in an acceleration or not? Yes, it is going with an acceleration. Alright, because that's the reason it is asked with the timing also, because that is an acceleration, definitely it is there. So draw the diagram first of all, and then we will be taking the two cases here. One is when the body ascends. Ascends means it is going upwards, right? So the diagram will be the same diagram what we have been drawing all the time. So now you would have got quite used to this diagram here, 30 degrees, and it is mg here, it is mg cos theta, and then this is going to be the value of r, mg sin theta. Now ascending, it is going upwards, so this is going to be the effort force, and this is going to be the friction force. Alright. Now the next line is when the body ascends. When the body is ascending, what will happen? So it means this F is going to be equal to these two things, mg sine theta plus Fk is equal to capital F mg sine theta plus mu mg cos theta is equal to m into a1. So we'll take it as an acceleration 1. This is the very first equation. You can keep it as equation number 1. Right? Now similarly, when the body is going downwards, what will happen? Then F will start moving in this direction, Fk. That's the only difference you will get when the body descends. So mg sine theta minus Fk is going to be equal to F mg sine theta minus mu mg cos theta is going to be equal to m into a2. Acceleration is a2. This one is, maybe you will take it as f2 here. This is f1 here. So you get that different value here. This is equation number 2. Alright. Now the next one, what we can do is, we can divide both this one. Dividing 1 and 2. Divide 1 and 2. So look at this one. ma1 upon ma2 is going to be equal to mg sine theta plus mu mg cos theta upon mg sine theta minus mu mg cos theta. That's only one difference. This one you have. The next line is divide this one, numerator and denominator, by you can divide it by sine theta itself, or you can divide it by cos theta. So anything you can put, then you will get the answer here. So we'll write divide numerator and denominator by cos theta. So a1 upon a2 is going to be equal to, so mg. So what will happen? Divided by cos theta, sine theta upon cos theta plus mu mg cos theta upon cos theta divided by mg sine theta upon cos theta. This is minus here, mu mg cos theta upon cos theta. So cos theta, sine theta, everywhere it is now substituted. Now how would you finally write a1 upon a2? mg you can take it common outside. And what this will become? Tan theta plus mu. Okay, cos theta will become 1 divided by mg common outside. This will become tan theta minus mu. This will get cancelled out. So you get here a1 upon a2 is going to be equal to tan theta plus mu upon tan theta minus mu. This is one of the next equation you will get. Quite simple, very very simple. You just had these two equations, you just divided both of them, and here top and bottom same cos theta you just divide and you will get this answer. The next part is, they have already given the time of ascent and descent. There is a relationship is there. You need to substitute and you will get the answer. So the time is t1 is equal to half t2 given. The time of ascent is equal to half the time of descent. So it is given here. Same distance it travels. Same distance it travels. Both times. That means S is equal to half u1 t square. Ut plus half at square, half a1 t square, t1 square is equal to half into a2 t2 square. So this is a kind of an same equation. Same distance it travels. Up also it travels the same distance. Alright, with an acceleration a1, and down also it travels the same thing with an acceleration. Down when it was there, it is going to be, the acceleration was a1, A1 was up and A2 was down. So the distance is same. So you get this equation here. Once it is same here, what is A1 upon A2 here? It makes it as T2 square upon T1 square. That one you can substitute directly here. So it becomes T2 square upon T1 square is equal to tan theta plus mu upon tan theta minus mu. What is T2 square upon T1 square? T2 upon T1 is going to be equal to 4 will be the answer, because look at this one. Based on this one, you put here 4 is equal to tan theta minus mu upon tan theta plus mu upon minus mu. Cross multiply. You are very close to the answer. Looks quite long, but it is very simple. 4 tan theta, I am just cross multiplying here. 4 tan theta minus 4 mu is going to be equal to tan theta plus mu. So it becomes 3 tan theta is equal to 5 mu. So what is the next value you can get? Mu you need to find out. Mu is going to be equal to 3 by 5 tan theta. 3 by 5 tan 30. And you will get answer. Mu you will get answer. So what's the answer? You need to find it out. The actual answer is 0.346 is the answer. That is mu. Alright children, please go through the question once again. It's quite a simple question. Just go through the video again. You will be able to get the point. So finally you get this answer. The technical problem is, the very technical problem is this part. The time of ascent and time of descent. How do you substitute? Till this much is acceleration is there. And then you need to just substitute the values and get the answer. Alright, we'll go to the next question now. So turn to question number 3, example number 3. So you need to turn to the few questions earlier. Now it's a very interesting question. This is a very important question. It has been asked quite some time in the examination also earlier. So please listen to this question very carefully. Quite simple. A chain of length capital L is partially lying on a table and partially hanging outside the table. Try to imagine this one. Can you draw a diagram for this? A chain, a long chain is there. Some part is there lying on the table, and the other part, the rest of the part is now hanging down outside the table. If the coefficient of friction between the chain and the table is mu s, what maximum length of the chain can be kept hanging so that the part of the chain on the table does not slide? So if you keep on pushing it a little more to the sliding down side, then at one point of time the entire chain will fall down. It is asked how much maximum you can keep hanging. So look at this diagram here. I made a diagram here. There's a table here and this is a chain. So how much this part can be kept very safe so that the chain doesn't fall down also. It is asked what is this L value. The L value, how much you can keep it hanging so that it will not fall. The entire length is the total length. What is the total length? Total length is capital L. So what is this length which is sitting here? The length which is sitting here is capital L minus small l. And the rest of the L is here. So that's what that matters. But remember, what will hold this one is how this weight of this one will be there depends on the friction. The frictional force acts this direction, Fs. The friction is holding this chain. If the friction doesn't hold, if it is very smooth one, entirely, even the little part is there, it will just keep on sliding down. Because of gravity, the entire chain will slide down. The frictional force acting on this much length is really holding it this one that side. Had it not been a frictional force, gone. So the frictional force is equal to the weight hanging downwards. This one has a weight m into g. Now that is a mass of this much of length is there. That length is going to be equal to frictional force. That's all. You have to just equate it. So it is very simple to see how it will figure out. So this much will have its own normal reaction here. So that's going to be equal to m into g. So accordingly we can find it out. Write down first of all. Let capital L be the length of the chain. Capital L is the length of the chain. The next one is, let m be mass per unit length. This is very, very important. Mass per unit length. Make it very, very clear. This is not just kg, it is kg upon meter. Mass per unit length. Alright, this is the mass. So the entire chain will have its m, means mass per unit length. Alright. Now the next one is, what is the let L be the part hanging down. So L part is hanging down. What is the mass of this much hanging down? Therefore, mass of chain hanging down. Mass is already m, mass per unit length, into L. So it's going to be m into L. So now what is the SI unit of this one? Mass of the chain hanging down. How is the SI unit? Mass upon length is already there, into length. So length it get cancelled out. So it's only kg is this one. So it is simple as that. Whenever you multiply mass per unit length into another length, then it becomes the mass itself of this particular part of the length. So this much from here to here, it is m into L, mass per unit length into L. So the next one is mass of chain lying on table. How much it is? Mass into the rest of this one. L, capital L minus small l. That is the mass. Okay, fine. Now things are quite defined now. So first of all, we need to just give that final shape of the equation and then finally solve this question. So if you have this mass of the chain acting here, now frictional force you can find it out. Frictional force on the part of chain on the table. So how much will be the frictional force here? Fs is going to be equal to mu into m into g. Mu into m into g is this value. So maybe I can write it as mu into r first of all, and then mu into mass. Mass is L minus capital L into g. So just trying to keep it a little more extended here. That's all. The next one is weight of the chain hanging. This chain is hanging here. How much is the weight is hanging here? W is going to be equal to m into g. What is the mass? You cannot put m just like that. Please remember m into L into g you need to put, because it is mass per unit length into L. So if the thing has to be living in equilibrium, if it is maximum you can put it here. How much it is going to be equilibrium? Then W should be equal to frictional force. If it should not fall, if the chain should not fall. So what is W? M L into G. What is this value? Mu into M capital L minus small l into G. G will get cancelled out. Mass will get cancelled out. Now you get the simple value. What is mu is going to be equal to? You'll get the answer here. Right? So in other words, you need to get only the small l. So L is equal to mu times of capital L minus small l. right? This is what you will get here. L only you need to take it other side. So it is nothing but L minus mu L. L plus mu L is going to be equal to mu L. So 1 plus mu is equal to mu L. So L is going to be equal to mu L upon 1 plus mu. This is the answer. I've just taken from here itself. L is equal to mu times of L minus L, and then I just multiply it inside and you will get this answer. This is quite an important question. Please remember, stepwise you need to go through it once again every time. So it is mass per unit length is a very important factor. Based on that one, we need to calculate the mass of the hanging one, mass of the one on the table, and equate this one, you will get the answer. Alright children, we'll go to the next question now. Yeah, let us go to the question number 5. It's quite a interesting question. A bullet of mass 10 kg, 10 grams, it is not 10 kg, it is 10 grams, is fired horizontally into a 4 kg wooden block resting on a horizontal surface. So you will find here, there is a block which is here, and a bullet is being fired straight. And it is coming, and finally it is going to rest on inside this block. Once it is coming in such a good speed, and there is a coefficient of friction also in between the block and this one, mu is given here, mu is going to equal to 0.25, and this is 4 kg, and this is 10 grams. Now as soon as it gets blocked, the bullet is embedded in the block and combination moves distance of 20 meters. It is just continuously moving for 20 meters. Now it is quite a long distance before coming to rest. So this one, now this whole thing, it is moved here for 20 meters. It is moved. Find the speed of the bullet just before striking the block. There is a bullet speed in which it comes. Find the V value of this one. So that is a question here. Now when it moves here, it moves with a good acceleration here. It moves with acceleration, and there is a frictional force will be acting here in the opposite direction. So that is all that we know. Now we need to find out the total mass of the system. Is going to be equal to 4 plus how much? 0.10, right? 10 grams. 10 grams is going to be 10 into 10 to the power of minus 3. It's going to be minus 2. So you get here, it is going to be 0.01 kilograms. That is the total mass of this whole thing. So the next one is frictional force, Fs, mu into R. So what is going to be equal to mu into the mass into G. So what is mu? Mu is 0.25. Mass is going to be equal to 4.01. This is the mass, and 9.8. And you can find out the value of mu s, Fs, you can find out the value. It's all given here. The total mass is, this is the value here. Okay. Then the next one is, once this is the value you got, now once this force, frictional force is constantly opposing, this has started from here and it is continuously moving with a kinetic energy half mv square. Because of this kinetic energy which is imparted here, it is able to continuously move for half mv square. So this kinetic energy when it is moved, and the frictional force will be constantly opposing entire of 20 meters. So frictional force is doing a work against the kinetic energy. So look at the final question, final conclusion of this whole numerical. It's just in a line it finishes. The work done against the frictional force is equal to the kinetic energy which is initially imparted. So kinetic energy of the block is equal to work done against friction. So what is kinetic energy against a block? It is half mv square is equal to work done is Fs into the distance here. So Fs is already, everything is given here, and you need to just substitute and get the answer here. Half into 4.01 into V square is equal to 0.25 into 4.01 into 9.8 into distance. How much? 20 meters. This will get cancelled out. Now only V square is there. V square is going to be equal to, this also goes up here. So it's going to be equal to 2 into 0.25 into 9.8 into 20. You need to finally find out the value of V. Do the calculation, you will get the answer. Right? It is actually, it will become 200 meter per second. That is the velocity in which it will come. Okay? So with this, the question gets quite completed. I'll just explain in a just oral way the question number 4. And I will not be working out, that will be the last part. You can just figure out how to do it. There's an example which is already solved also. A particle of mass 1 gram executes an oscillatory motion on a concave surface of a spherical dish. So on a concave surface here, it is just going through a oscillatory motion here. Okay. So of the spherical dish of radius 2 meters. So the whole radius of this one is going to be equal to 2 meters here. If the motion of the particle starts from a point on the dish at a height of 1 centimeter from the horizontal, 1 centimeter from the horizontal, so from here, this height, it is just gone for a 1 centimeter height. 1 centimeter height it is gone. So this particle is just hanging here like this, right? It is hanging here like this, and it's going to come down, oscillatory motion. It is going to come down and then come like this. So from the horizontal plane, and this is the value of the friction. Now it is asked how much total distance will be moved by the particle before it comes to rest. Now what is the distance here, it is asked. Right? Now it is quite simple here. This is going to just keep on rubbing down and coming. This entire of the concave surface, it is just keep on rubbing down and coming here. So there is a frictional force always acting against this one. And this is going for an height. This is going for a height. So it is going to be called as mgh will be the potential energy. That potential energy will finally transform into the mgh, the potential energy will be transforming to the frictional force into the distance here. In the earlier question, we saw half mv square is going to be equal to ms into the frictional force into the distance. Distance or the s was there. So that was the earlier question we saw. Now here, it is raised from here to the top. 1 centimeter height it is gone. It is mgh. Mass, gravity into 1 centimeter height is equal to, when it comes down, this entire energy acquired by the potential energy will be slowly coming and finally finishing it by the frictional force acting on this one. And how much length it's going to be there, how much length it's going to cover, it is going to be, it depends upon this equating. Now look at this one. Look at this one. It is already given here. Fk is equal to mu into m into g, and work done is going to be equal to frictional force into the distance, and mgh is going to be equal to frictional force in the distance. The mgh is going to be equal to frictional force in the distance, and you can find out the distance here. Okay. Alright children, with this I close. You need to do the numericals here at the back. The numericals at the back is given here as the questions. Please turn to page number 289. Page number 289, and you will be doing the last 5 questions. 7, question number 7, 8, 9, 10 and 11 is the homework for you. Okay, thank you.